Limacons, your two equations are r equals a plus or minus b cosine of theta and r equals a plus or minus b sine of theta. So you should have your homework out on your desk right now, and anything that has a addition or subtraction sign is going to be a limacon. Now, you are going to have to be specific in which type of limacon it is. So I'm about to go over that. The first type of limacon is the general limacon. And what makes the general limacon? How do I know it's a general limacon? The absolute value of A is greater than the absolute value of B. Meaning the number before the plus or minus is bigger than the number after the plus or minus. I like to think of, somebody even said general is like, I think of that like in military terms, it's the top dog type thing. The first person is bigger than the second person. Okay, that's how I remember general. Also, you could say that A divided by B, the absolute value of that, is bigger than 1. What is special about the general limacon is it does not pass through the pole. The general limacon is the only limacon that does not pass through the pole. Write this down with me, please. The example we are going to graph is r equals 2 plus 1 cosine of theta. Now, what do we notice about these numbers? 2 is greater than 1, therefore it is a general limacon. In order to graph these, I want your picture to look nice. Of course I want your picture to look nice. But I am going to be paying attention to your quadrantal coordinates. So, r theta, we are going to graph 0 degrees, 90, 180, and 270. And what I'm about to do is just plugging in these numbers into theta and solving it. 0 degrees. What is the cosine of 0 degrees? Times 1 plus 2. 3. So please plot the point 3, 0. What is the cosine of 90 degrees? Times 1 plus 2. Please plot 290. Does everybody see how I'm coming up with these points? I'm just plugging into theta. The cosine of 180 times 1 plus 2. And the cosine of 270 plus 2 is 2. On your homeworks, you have Desmos at home. I want you to graph these without using Desmos. You're not getting Desmos on this test. However, just to make sure that your shape is nice and pretty, I am okay with you, after you plot the points, if you want to look and to make sure that your graph looks about right, this is what your graph should look like. Now, when you're connecting these points, please make sure that one is not pointy. Does that make sense? So I like to do these right here first. Kind of make that C. And then these over here next. As long as you have these 4 points graphed and it's not pointy, you should be good. That is your general limacon. Do I have any questions? Can I answer anything about this? Can I move on? Number 2. Anybody remember another one? We're going to do inner last. Cardioid. The cardioid limason is what I heard somebody say. Cardioid makes you think of what? What word? Cardio. And cardio has to do with your heart. A cardiologist is a heart doctor. I know y'all personally think this looks like something else. We're going to say it looks like a heart. Cardioid. And how you look at an equation and know it's a cardioid equation? Because your A is the same, the absolute value of A is the same as the absolute value of B. They're in love. They're the same. Cardioid. So if you can remember hearts, love each other, they're the same, that's how you can remember cardioid. Or you could say the absolute value of A divided by B. I don't want to know what y'all are making up in your heads right now. But A divided by B is 1. And cardioid always passes through the pole. And it actually doesn't pass through it. It does hit it, but it actually bounces, which creates that lovely heart shape. So the example we'll do here is R equals 2 plus 2 cosine of theta. What do I know? Two equals 2, therefore cardioid limason. And I can write or make my table. All right, 0 degrees. What's the cosine of 0? Times 2 plus 2. Please plot 4, 0. $90. What's the cosine of 90 degrees? 0 times 2 plus 2. And do you agree that's also the cosine of 270 is also 0? So I'm going to get 2 as well at 270. Are y'all okay with that? And then the cosine of 180, negative 1 times 2 plus 2. Which doesn't really help us for our shape, does it? Now, if you wanted, you could use your pi over 3s. Because what is the cosine of 60 degrees? What's half of 2? Plus 2. And that would be both 60 and 1. So you don't have to use those. Is that one of your quadrantals? No. I'm not going to grade that. But if you want to have a more accurate shape, that might help you. And the same thing, you could do 120 and 270 as well. All right. I want to show you what this looks like just so you can kind of get an idea. Again, you're not going to have this on your test, but do you see how wide that is? It's a heart, a sideways heart, but it's not pointy. Please do not make this point right here. Please do not make that pointy. All right, that's a big common mistake. So I'm going to use a pencil because I'm not very good at drawing these right off the bat. There we go. And do you see how it bounces at the pole? We could call it a peach. Peaches are good for your heart. We can remember it that way. Yeah. Any questions about cardioids? All right, last one is the inner loop. Inner loop, how do you know if it's an inner loop, Limason? A is less than B. And the way I remember this is it's inner. It has the word inner. The inner number is bigger than the outside number. So absolute value of A is less than the absolute value of B. Or A divided by B is less than 1. For this one, inner loop, Limasons, always go through the pole twice. Because it does make that loop. It always goes through the pole twice. So if I give you r equals 2 plus 3 cosine of theta, 2 is less than 3, therefore inner loop Limason. Am I going too fast? What's the cosine of 0? Times 3 plus 2. Plot 1, 2, 3, 4, 5, 0. Cosine of 90? 0 times 3 is 0 plus 2. And do y'all agree that's the same for 270? What is the cosine of 180? No, cosine of 180. Negative 1 times 3 plus 2. So I'm going to graph this 1 away from 180. Again, just to show you what that looks like, that you won't have, but all right, inner loop. So let me grab this right here. As long as it's not super pointy right here, you should be fine. As long as you show me your 4 quadrantals graphed, you're good. On Thursday, I'm going to give you, we're going to have homework over this and we're going to trade and grade, but I'm not going to be able to look at it, but I'll tell you what I'm looking for and what I'd count off for when we trade and grade homework. Okay? I believe on your test, you are going to have 5 of these to graph. Not Limasons, but 5 graphs, period. 8 points each, I think, is what we're doing. All right. Yeah, I mean it's 40 points, yeah. All right, can you get out your homework, please? I feel like you probably, of all of these, want me to go over some more rose curves. Do you feel like that too? You feel like you got rose curves down and you're good? All right, before we do that, this first column right here, 1 through 28, right here. I would like you to just look at them on your blue paper and write down what type of curve they are. That's basically your quiz tomorrow. Look at the equation. Can you tell me the type of curve it is? Just do this first column. Go. All of it. Line, circle. It's all I want. It could be a line, it could be a circle, a rose curve, a limniscate, or a limaçon. Blue paper, first column. Let's go. You have your blue paper? It's from the old one. Get it out. Practice for your quiz tomorrow.
Where did we write this down?
Where did we write what down at? I'm going to give you 1 more minute. I think you're going to have 3 minutes to name 10 of them tomorrow. 10. And it's just matching. You don't have to actually write out the words. So you're writing letters. You shouldn't need that. That's the whole quiz tomorrow. Just matching. Let's see if you got them right.
Can you explain why?
Yeah. Let me give you all that minute I actually said I was going to give you. I'm going to take attendance.
I don't even know how to spell it.
All right, number 1, R equals is a circle. Number 2, theta equals is a line. You would draw a line at 3 pi over 4 through the pole. If I just give you sine or cosine with one number, that is a circle. A rose curve would have a number with it before theta. A rose curve would have 2 numbers. Okay, what if I give you a plus or minus? It's a limaçon, but what kind? Here's my A, here's my B.
It's a cardioid.
Why is it a cardioid? They're the same. They're both 1. Do y'all agree with that? 13. What is this? What kind of limaçon is this? Because it has a plus or minus.
General.
A is bigger. It is general.
Do we have to write limaçons?
Yeah. Again, your quiz is going to be matching letters. So yeah. All right. 16 is also a limaçon because it has a plus sign. It is a general again. A is bigger than B. What about 19?
Inner loop.
Inner loop. So this is where the absolute value comes into play. Yeah, that's -3, but you're just looking at the number. Your B is bigger than your A, so this is an inner loop limaçon. 22, rose curve. 25, why is it a limniscate?
R².
If you have R squared, it's a limniscate. And then 28. General, there's a lot of generals. General Limacons. Because your A is bigger than your B. Can y'all do that on your quiz tomorrow?
No.
Okay, you're going to be studying tonight for that.
Why is 7 a circle and not a rose curve?
Why is 7 a circle and not a rose curve? Because there is not a number between theta and cosine. A rose curve should, correct. So circles are just sine and cosine. Rose curves have two numbers. Limniscates have two numbers, but with R squared. Yep. Okay, I want you to flip in your answer sheets. Can you flip over to page, or problem number 21? We're going to do 21 and 23 together. So I already did 21 for first period, so I'm just going to make this my number 21. Everybody flip to problem 21. The equation on 21 says R equals 3 cosine of 2 theta. Flip to 21. This is a rose curve. Okay. As a reminder, rose curve tables are different. Look up. This right here is 2 theta, so you're going to have an extra column for rose curves. But you're still going to do your quadrantals. 0, 90, 180, and 270. And we're going to plug in. What is the cosine of 0 degrees? 0 times 3? No, what's the cosine of 0 degrees? 1 times 3? 3. What is the cosine of 90 degrees? Times 3? And do y'all agree that's 270 as well? And then what is the cosine of 180 degrees? -1 times 3? -3. Does everybody see how I just plugged in the quadrantals and got points? Just like we were doing for the Limacons. The difference for rose curves is what we just plugged into was 2 theta. I want to know what theta is. So what am I going to have to do? Divide by 2. And I'm going to divide all of these numbers by 2. So these no longer matter. Our quadrantals no longer matter. I need to zoom in for y'all. See y'all. I'm going to plot 3, 0 as my first petal. Then 0, 45 is just the pole. And then -3, 90. I'm going to go 3 away from 90. That is my second petal. What do I know about this rose curve? How do you know there are 4 petals? Edwin, write this down. Because it's even, you double it. So there are 4 petals. What else do I know? Louder? Each petal is going to be 3. What else? Say that louder. Oh, who said 360 divided by? Oh, 360 divided by what? 360 divided by 4 tells me how far apart each petal is from one another. 360 divided by 4 is 90 degrees. So I know each of these petals are going to be 90 degrees apart. Does that make sense? It told me to start at 3, 0, go to the pole, and then go right here. Where is it going to take me to next? To the left. So this is my third one. And then, let's actually go through the pole. And this is my fourth curve. And there we have our rose curve. Does that make sense? Is it weird? Weirder than the other ones for sure. Let's do one more just so that you don't have to question it. We're going to do 23 as well. Are we sure? I have no questions. Okay. 23 is R equals 4 sine of 5 theta. We're doing 23. Right next to it. Do y'all agree this is also a rose curve? What do we know about this rose curve? Huh? 5 petals. Therefore what? $360 divided by 5 is, each one is going to be 72 degrees apart, which is going to make this fun. So I'm going to add 5 theta here, and let's plug in our quadrantals. What is sine of 0? Times 4? 0. The sine of 90. 1 times 4. Am I going too fast? Sine of 180. 0 times 4 is 0. And the sine of 270, negative 1 times 4 is, what do I do now? Divide it by 5. So that's going to give me 90 divided by 5 is 18. 180 divided by 5 is, and 270 divided by 5 is, so this is going to start at 0, 0 and go at 18, which is a little past that first one. 1, 2, 3, 4. That first one is 15 degrees, by the way. This is my first rose curve. It's going to make a full petal. Because then at 36 it goes back to 0. 54 is going to be somewhere over here, but it's negative 54. So 1, 2, 3, 4. It is then going to travel over here for the second petal and go back to 0. You could keep this up and keep doing the table. I don't want to, though. What can I do instead? Do the math. Don't you agree I'm at 18 degrees? What do I know about each petal? They're 72 apart. So what is 18 plus 72? there's going to be a pedal at 90 degrees. Plus 72. There's going to be a pedal at 162 degrees. Oh, I did that wrong, didn't I? Hold on, I graphed that wrong. That's supposed to be 1 up. If I add 72 to that, that's 234. That's about what that is right here. And if I add 72 to that, that's 306. There's 300, so that's like about right here. How do I know which one it goes to next? You could follow the curve. Where's the curve taking you though? If you don't know, count. How far apart are 1 and 2? 2 pedals. Do y'all see that? Look up. 1, 2 pedals. 1, 2 pedals. This is going to be your 3rd pedal. From your 3rd pedal, 1, 2 pedals. Here's your 4th pedal. 1, 2 pedals. There's your 5th. So that way it can kind of guide you. To do your pedals. Okay? That is all I'm going to do for you today. What I would like you to do is get started on your evens. They're due when you walk in on Thursday. Y'all have about 25 minutes. No, that's wrong. Y'all have about 15 minutes to get started on this. I mean, at least what you could do is just name write the equations down and name all the types for the evens before you leave today.